quantum physics being the most successful branch of physics in science. It's the most successful branch of science is quantum physics. Quantum physics it definitely captivated my mind. I remember when I was in school, in science class, and the teacher was teaching us about atoms. And one thing that I never forgot was where she said that atoms actually repel each other. You don't really touch anything, because once you touch something, the atoms on your finger and the atoms of that object actually repel each other on a subatomic level, and you're actually just suspended in air so you're actually just suspended in air at all times on a subatomic level. The atoms of your feet are not really touching the atoms of your sock. Your sock's not really touching your feet. Your shoes never touch the ground. The energy of those atoms, they repel each other as soon as they come in contact. Well, they don't really come in contact. They never touch. Like right now, it looks like I'm touching the steering wheel. It looks like, and it seems solid to me, but that's actually an illusion. I'm not actually touching it, and it's not actually solid. Man, quantum physics will take you into a fucking mind trip. If quantum physics has not profoundly shocked you yet, then you don't understand it. But once you do understand it, man, it all makes sense. Man, life is abundant. It really, really is. Abundant life, man. Breathing in that good ass prana, baby. Shout out to Ralph Smart. In order for you to start seeing the abundance, you're gonna have to start looking for it. Because most of the time we're raised to see lack and limitation, to put ourselves in a little box of limitations of things we can and can't do. And these things, we pick them up along life as we grow up. We see our parents, we see our parents and the things they do, the things they complained about, the things that made them fight. And we unconsciously pick these things up. And these things shape and mold our lives, man. They make our lives. See, because what the double slit experiment, which is the most famous experiment in quantum physics, it showed us that whatever the conscious mind, the observer, is looking for, that's what he will find. Whatever you decide to look at, however you decide to look at it, that's how you're gonna see it. It's going to show you what you're looking for. So if you go out here and you look for lack and limitation, there's going to be an abundance of lack and limitation. But if you come out here and you look for opportunities and abundance, there's going to be an abundance of opportunities and abundance. Whatever you decide to focus on is whatever your mind is going to show you. These atoms are going to go from a hazy wave state of being invisible See, because quantum physics shows us that every single possible outcome already exists. It's already out here, and it's somewhere out here in this invisible ether, in the form of waves, of hazy wave state. The atoms, they go from being in all possible outcomes. They're everywhere. Every single outcome out here is already completed. Whatever you decide to look at, whatever you decide to see, those atoms will collapse into solid particles. Now, you're not going to see it happen right before your eyes. You're not going to see it switch right in front of you. But they will switch. It's a crazy fucking process, man. So these scientists, they say that, let's say there's a tree in the middle of the forest and there's no eyes around to see it. There's no central nervous system to take in those vibrations and translate them into the tree. They say that if there's no conscious awareness on that tree, then that tree does not exist. It exists in the form of a hazy wave state. The atoms, they're not collapsed into solid particles up until the moment up until the moment that you have a conscious observer, a conscious mind looking at it. Then it collapses into solid particles and it makes a tree. That's fucking insane. That's fucking insane. But this is scientists saying this, fucking physicists, not me.
And that's why it's very, very important for you to focus. That's why it's very important for you to stop letting your mind run rampant, running all over the fucking place. Don't even know how the hell you're thinking of some of the things you're thinking about once you do realize you're thinking those things, man. Your mind just runs off. And you don't even try to catch it, you just let it go. And it's pulling to you all kinds of bullshit because you're not focused. Because you're not focused. See what you're doing whenever you focus on the negative outcome, you're collapsing all the negative outcome possibilities into solid particles, into stuff that you can see. And you're doing the same thing when you focus on all the positive outcomes. You're making all the negative outcomes go away. The only possibilities that are going to be left are all the positive ones. It's kind of hard to understand, I know. But how do we know this? How do we get to this point? How did we get to this perspective? Well, again, it's the double slit experiment. In a double slit experiment, what they did is they put a wall, and then in front of that wall they put another wall with two slits in it, two slits, one on the left, one on the right in the middle of the wall, and they started to shoot tennis balls through these slits, and they would measure where the tennis balls were landing, and of course they were landing right behind the open slits. So they took the tennis ball machine away, and they did it with electrons, which are tiny particles, tiny solid particles, microscopic solid particles. So they shot these electrons one by one through these slits, and to their surprise, they did not land right behind the two open slits. They actually formed a pattern, a wave pattern. Whenever you cause a ripple in water, let's say you cause a ripple in front of these two slits, and a wave goes out, it hits these two slits, and on the other side, it causes more waves. And then in the back of the wall, wherever these waves meet, they land on the back of the wall in wave patterns. So not just the two slits, but also to the left and the right, two more spots. So they were landing where the slits are at. They were going through the slits, and then they were spreading out. And then once they hit the back wall, they had multiple spots on that wall where that wave was hitting in water. But when they started to do this with electrons, which they thought were solid particles, and they should behave exactly like the tennis balls, but they didn't, and they actually behaved like a wave, like an ocean wave. So they were like, "What the fuck?" So they started to observe it. They put a camera right there to see what the fuck was happening. And the moment they put the camera, it wasn't acting like waves anymore. It was acting like the tennis ball. So they weren't spreading out anymore once they had a conscious observer looking at it, a camera. And they were like, what the fuck? So they were acting just like tennis balls again. And, and so whenever they put the camera there, whenever they put the camera there, they started to observe that they were acting like solid particles instead of a hazy wave state. So what they did is they put a camera behind the two slits and in between the back wall and the two slits. They put a camera right there. And they started the electrons. It started as a wave. But the moment that these atoms found out that they were being observed behind the wall, they instantly collapsed into solid particles and started behaving like the fucking, and they started behaving like the tennis balls. So whenever a conscious observer wasn't looking at these atoms, they were acting like a wave, like an invisible wave. But the moment they put cameras on there, they collapsed from waves into solid particles. And then they started to realize that when they're in a hazy wave state, they're actually existing in every single possibility at the same time. But the moment that a conscious observer looks at these atoms, they collapse into solid particles that we can see. Quantum physics is very, very fucking strange. Very strange. That it shocks you, man. It mind boggles you. So that means for your life is made out of atoms. These atoms that they did these experiments with. Your body and everything is made out of these atoms. They act the same way. So whenever you're looking at your life and you're scared of something happening, guess what? Guess what? Whatever you decide to see is whatever you're going to see. That's why it's important for you to focus, man. You have to build the vision. You have to build a vision of your future, of how you want your future to be. And if you focus on that, those atoms will slowly start to collapse into the chosen outcome that you've decided to go with. So if you just start something like, well, we'll see where this takes me. We'll see what this has in store for me. Guess what? You're not gonna fucking like the outcome. Because if you're leaving it up to possibilities and hope this works out for you, and hope that this happens, and hope that you don't fucking fail, and hope that you succeed, if you're just leaving it up to hope, then you're not directing your life how you want it. If you go after this thing and you don't believe you can have it, then it's not gonna happen. You have to believe it. You have to believe it. Remember, a belief is just a thought that you repeat more than any other thought. It's just a thought that you've repeated in your mind way more times than you've repeated other thoughts. See, there isn't anywhere in your brain that holds your beliefs. Beliefs are just repeated thoughts. Repeated thoughts over and over and over and over again. That's a belief. Whenever you repeat a thought multiple times, so many times like that, it goes into your subconscious.
A famous experiment in quantum physics called the double slit experiment, which exposed something about particles that still surprises us today. Particles display both particle-like and wave-like behavior. In a version of the experiment, on a larger scale, we have a gun that shoots tennis balls one by one at a detector, which will register where the tennis balls land. In between the gun and detector, we place a barrier with two slits, which will leave openings for any tennis balls to go through. Over a period of time and after many tennis balls, a pattern emerges on the detector, indicating where the tennis balls have landed. The results show that the balls which have not been blocked have landed directly behind the slits in the barrier. If we replicate this experiment but on the subatomic scale, have landed directly behind the slits in the barrier. If we replicate this experiment but on the subatomic scale and use electrons instead of tennis balls, we expect similar results. But this was not the case. Scientists found that when the gun shoots electrons one by one toward the detector and past the double-slit barrier, the pattern that emerged on the detector looked like this. The electrons landed not just behind the two slits, but in narrow strips across the length of the detector, and a significant number of electrons even landed straight behind the middle of the barrier. The pattern that emerged is an interference pattern and is associated with the behavior of waves. Imagine we have two waves that interact. The peak of the waves will combine to form a higher peak, and the troughs will combine to create a deeper trough, and when a peak and trough meet, they will cancel each other out. So observe the electron's wave function going through both slits at the same time. Detectors were placed next to the slits to capture this activity. But when this was done, something strange happened. The electrons stopped behaving like waves and went through one or other of the slits and landed on the detector screen to form the two-striped pattern rather than the interference pattern. It seemed as if the act of measuring did something to collapse the wave function. The superposition principle. The superposition principle states that while we do not measure the electron for its position, it is in all the possible positions it could be in at the same time, and when we observe it, the superposition collapses. So in this illustration, when our detector is off, our electron is in all of the possible positions or states it could be in simultaneously. But when we switch our detector on, the superposition collapses and the electron gives up all of its possible states to choose just the one. That is why we were not able to observe the electron